Alright, I just graded your in-class practice for chapter 16 to 17. I see a lot of common problems from this in-class practice. I need to say that there is a big difference between before exam 1 and after exam 1. So before exam 1, you have the steps to follow. As long as you have the right formula and then you just follow the steps, you should not have big problems. But after exam 1, you need to focus on understanding the materials. We do not have, of course, we have several formulas that you need to follow to calculate, but the main point is not calculation. The main point is you need to know which formula is using, or based on the question, what they are asking about. Right? You need to understand the materials. That's why I strongly suggest you to watch the videos. I even want to record you, but I cannot control it, right? So I strongly suggest you to watch the videos. In the videos, there are many small details that can help you to understand the material. Right, without looking at chapter notes, without looking at videos, you will have some problem. I don't know which problem you will have, but 100% you will have problem with answer the questions. All right, so just to consider yourself as just in the regular time, right? So download the chapter notes, read through it, and then watch the video just like you are in class. Right? I don't think there is any difference. I can even explain more details in the videos than in the class. So I think you should have better understanding than in the class. All right, so let's come back to this in-class practice. The first question, write down the true regression model for car price and mileage. All right, be careful. The question is asking you to write down the true regression model. All right, when did we talk about the model? Right, we say the true regression model is talking about the population, right? So let's come back to our chapter notes. Remember this table? Right, we say what? We say we want to estimate the population, but we cannot do everything about the population. That's why we choose a random sample, so that based on this sample, we can estimate the population, right? So based on the sample, if you have a random sample, then based on the sample, you will get a sample regression equation. Right, so here, this is the sample regression equation for prediction. All right, and once you have this sample equation, you should have a detailed value for B0. You have detailed value for B1. And then what? You can use B1 and B0 to estimate the population parameter, which is beta 0, beta 1. All right, then this is about the sample. This is about the population. So when we talk about the population regression model, we are talking about this one. Right, so as I said in the video, we never know about the value of beta 0 and beta 1. So what is the population regression model? Here we only have one explanatory variable, mileage x, right? So what is the true regression model? It is mu of y equals to beta 0 plus beta 1 x. That's it. All right, we are talking about the population. So first, we do not want to make the prediction. We do not focus on making prediction. We want to get the mean value of y, which is we use mu of y, and then we have beta 0 plus beta 1 x. Alright, so this is the model. Now we have the model. Next question. What is the simple regression equation for the car price and mileage? Right now I'm asking about the equation. That means this equation is from the sample, right? So this is the output based on the sample, and you have the parameter estimate table. So this is B0, this is B1, right? The whole row here is about beta 0, the whole row here is about beta 1, right? Okay, so what is the simple regression equation? We plug in the detailed value of B0 and B1. So we say generally it is y hat equals to B0 plus B1x. But since you have the output, you have the detailed value for B0 and B1. So what is the simple regression equation? Will be y hat equals to 21710.626 minus 0.123316x. Alright, so this is the simple regression equation. Some of you just use the round to one digit or even keep the integer, right? I will not suggest you to do this because what? Because even though this is a small number, x is a big number, right? So x is the mileage of a car. It will be a big number. So if you times a big number, if you run to just a 0.1, missing the other digits, you will have a big bias. Alright, okay, so here I want you to keep as many digits as you want because you don't want to make the difference too big, right? Okay. Alright, let's continue. So number 3, what will be the predict price of 2012 Honda Civic that has been driven for so many miles? Alright, so now we want to get the predicted price. Remember, the predicted price is based on the equation, right? So now what is this many miles? This is the value of x, right? So to get the predicted value of y, you need to plug in the x value into your equation so that you have y hat equals to 21710.626 minus 123316 times 37500, right? If you calculate this, you should have 17098.126. Alright, so this is the predicted value based on this equation. The question is asking what will be the predict price. So what is the predict price? It will be this price. Alright, so for this question, it is easy because we use these many detailed miles. But what if I ask you what will be the predict price of this has been driven for 3, give you x value is 37.5, where x is in, let's say, 1,000 miles. That means now you have a unit for the x, right? Then when you plug into the regression equation, you need to be careful. But for this case, for our in-class practice, you don't have this problem because the x is just a one single mile, right? Okay, so here I will erase it. Don't want to confuse you. Alright, so next one, number 4, calculate and interpret 95% confidence interval for mean price of a car with same miles, which is 37500. Alright, and I see the common problem with number 4 and number 5. So number 5 is to calculate and interpret 95 prediction interval for the price of a car with the same miles. Alright, so actually we are getting the confidence interval and prediction interval. Right, so now let's review a little bit from the chapter notes. Right, we have a separate section, right? So we say since this y hat has two meanings, right? Y hat in this sample regression equation, it predicts a individual value of y based on the x. But this y hat also have another meaning because this is about the sample. We want to use the sample to estimate the population, right? So we say we want to use the y hat to estimate the mu of y, which is the mean value of y. So here we have the y hat has two meanings. The first one, it estimates the mean value of y when x has a specific value. And also this y hat predicts a individual value of y. So this is about the individual value of y. But both of these two are pointing to this y hat. Right, so based on these two different meanings of y hat, we can get the two kind of the confidence intervals. So first, the confidence interval for the estimated mean value of y, we just call it is the confidence interval. And for to make separately, we have the confidence interval for the predict individual value of y based on the x. We call it is prediction interval. All right, then let's come back to our question. The number 4, calculate and interpret a 95% confidence interval for the mean price of a car. So we have the mean price of a car with two meanings, right? Mu of y and for a single prediction, right? Okay, so this question is asking about for which meaning? It's asking about the confidence interval for the mean value of y, right? And then we have the corresponding, just the formula, right? Okay, so this is the formula for the confidence interval of the estimated mean value of y. So here we just write down the formula. We have y0 hat plus minus t star times standard error of mu 0 hat, and where we say standard error of mu 0 hat equals to square root of standard error of b1 squared times x0 minus x bar squared plus se squared over n. Right, I know this is a long formula, but it doesn't matter, it's just a calculation, right? We just plug in the detailed value for each of them, it will be okay, right? Okay, so now let's calculate the standard error of mu 0 hat. First, you need to find the standard error of b1, right? So standard error of b1, where is it? We say in the parameter estimate table, the first row is about beta 0, the second row is about beta 1, right? So we have B0, B1, then correspondingly for this column, it is the standard error of B0, standard error of B1, right? So what is the standard error of B1? Will be just this. Right, so this is the standard error of B1, all right? Okay, then we just plug into the formula, so it is 0.012514 squared times x0. So what is x0? let's just list all the necessary numbers. So we have standard error of B1, which is 0.012514. And then we need to find x0, we need to find x bar, we need to find SE, we need to find N. Right? Okay, so next, what is x0? x0 is the value you plug into your sample equation so that you can get the y0 hat, right? So what is the value? Will be 37500, right? You plug in this into your regression so that you have this value in the number 3 question. So this is just your y0 hat, right? So this is x0, and then you plug in x0 into the equation so that you have the y0 hat. All right, so now you have x0 is 37500, right? So we have 37500 minus x bar. All right, so here I think I kind of confused you with x bar because when I make the question, I forgot to mention what is x bar. That's why I add in the assignment page out of this assignment, out of this file. I just make it in the page of it, on the page of the assignment. So x bar listed on the assignment is 35000. It is given to you. You don't need to find from this output. If I have the summary statistics table, then you can find the x bar, which is the mean value of x. Right? Some of you used this value as the x bar, which is not right. Right? So for this value, you see it is the mean of response. So what is response? Response is y, right? So this is the mean of y, which is y bar. It is not x bar. All right, okay, so be careful. All right, so then we have minus 3500 squared and then plus SE. What is SE? SE is also called the root mean square error, right? So this is your SE, right? So which is 480.8307, right? So just plug into the number 0.8307 squared divided by n. What is n? N is number of observations, right? So which is 18, right? So you have the n is 18. Alright, so what else left will be just a calculation, right? So when you plug in the numbers, be careful. Here is a square, here is another square, here is the third square. Alright, so after you calculate this part, you should have equals to 117.57. Alright. So now you have the standard error of mu1, then what is the confidence interval? Will be y0 hat, right? So we just said y0 hat is when you plug in the x0 into the equation, the value of y will be the y0 hat, right? So which is 17098.126 plus minus the t star. What is T star? The T star is, alright, so what is T star? Here we have the T star, which is our critical value, right? So we say the critical value, it will be the T critical value will be based on the degree of freedom and alpha over 2, right? So what is our degree of freedom? N minus 2, right? So which is 18 minus 2, which is 16. right? So this is our degree of freedom. So what is alpha over 2? Alpha is the opposite of 95%, so which is 0.05 divided by 2, which is 0.025, right? And then we need to go to the t table and then combine these two information in the t table to find the critical value t star. Right? Okay, now let's come back to our t table. That means we have the degree of freedom is 16, right? And then we need to combine with the alpha over 2, which is 0.025, and then your t star is 2.12, right? Okay, so since here I have already talked about a lot before exam 1, so I just skipped in this chapter video, but it looks like some of you still don't get it, so it will be 2.12 times the standard error of mu 0 hat, right? So which is 117.57. Right, so now again just left with the calculation, right? So you will get 16848.87 to 17347.38. Right, done. Right, next, and to interpret it. Right, so to interpret this confidence interval is easy because we say we are 95% confident that since we are getting the confidence interval for the mean value of y, right? So which is the mean price of cars with the same mileage of 37500 miles. Alright, so now this is done, and let's work on the next one, right? Next one is the prediction interval, right? Okay, so now let's come back to the notes. We say the prediction interval, there's nothing different with this part, with the t start, or even in the standard error of y0 hat, the first part will be the same with the confidence interval. But for prediction interval, we will have more random error. That's why we have an extra term here, right? And then we will have the formula, right? So first, which is the y0 hat plus minus the t star times the standard error of y0 hat. Alright, and then where we say the standard error of y0 hat will equals to square root of the same with the confidence interval, which is se square ob1 times x0 minus x bar squared plus se squared over n, but with a extra term of se squared, right? And since we have all the information in this part, right, and then we just plug in the numbers. So we have 0.012514 squared times 37500 minus 35000 squared plus SE, which is 480.8307 squared over 18, but we have an extra term, which is 480.8307 squared. Alright, I know it is a long calculation, but it is just a calculation, right? So after calculation, you should have it equals to 494.99. Alright, and then what is the confidence interval for the prediction of the single y value. You just plug in this into this equation, right? So here I just change another color so that you don't get confused with each other. Let's say blue. Right, and then the confidence interval will be y0 hat, which is the same 17098.126 plus minus the t star, which is the same because the n is not changed, the alpha over 2 is not changed, right? So it would be still 2.12 times the standard error of y0 hat, which is 494.99. Then after calculation will be 16048.73 to 18147.52. Alright, and then how you interpret it will be similar, but now we are having the confidence interval for the prediction of a single car, right? So to be different with the previous one, we say we are 95% confident that the predicted value of the car price with the 37500 miles is contained in this interval. Right? Okay. I think I missed some words. Is contained in this interval. Alright, okay, so this is number 4 and number 5. And I think the main problem for these two questions is to choose the right formula. And then once you have the right formula, you just plug in each of them so that you just find the corresponding values in this output, right? And then just a calculation. Alright, okay, so number 6. What is the standard deviation of residuals? Right, so first, what is the standard deviation of the residuals? What is the notation of it? Standard deviation of residuals, just SE. Alright, so how to find the SE? We say SE is also called the root mean square error in the output. Right, so what is this? So that means SE is just we just found in the last question, right? SE is just 480.8307, right? So SE is just 480.8307. This is the answer, right? Is that easy? Right, so next one, what is the estimate for beta 1? So estimate for beta 1, what do we use to estimate beta 1? We use B1, right? Okay, then what is the value of B1? From the output, we have already know that the value of B1 is here, right? So the estimate for beta 1 is just negative 0.123316. That's it. Alright, so let's continue with the next one. I just copied another output here so that we don't need to go up and go down. Alright, so number 8. What is the standard error of B1? So first, standard error of B1, where to find it? We say this is B0, right? This is B1, right? And then correspondingly, this is the standard error of B0, right? So this is the standard error of B1, right? So this is the standard error of B1. So standard error of B1 from the output, which is 0.01251514. That's it. All right, next, what are the hypotheses to test if the regression is meaningful? Right, so we say we have the population model, right? We have, because when we do the hypothesis test, we always test about the population, right? So this is the population model. What do we need to test? We need to test about beta 1, right? So we have already talked about that in the video. We need to test about whether beta 1 equals 0 or beta 1 not equals to 0. Right, so this is the hypothesis. And next, what is the test statistics? So first, what test statistics? Is t-test statistics or z-test statistics or chi-square test statistics? Or even in the next chapter, you have f-test statistics, right? So first, you need to decide what is the test statistics. It will be, for testing about beta 1, we have t-test statistics, right? Okay, now where to find the t-test statistics? You don't need to calculate by the formula. It is given here. The t ratio is our just a t-test statistics. All right, so this is your test statistics, which is just a negative 9.85. That's it. All right, if you use the formula, it's fine. You just use B1 divided by the standard error of B1. You should have this one divided by that. You will have the t-test statistics. You should have the same value. All right, next, what is the corresponding degree of freedom? We have already talked about that, right? Degree of freedom equals to n minus 2 for the simple regression, which is 18 minus 2, which is 16. All right, next, at alpha equals to 0.05, what is the conclusion? Right, so when we have the hypothesis test, if we want to get the conclusion, we need the p-value, right? Okay, we want to compare the p-value with alpha to say reject the null hypothesis or not to reject the null hypothesis. So first we need to find our p-value, right? Okay, so how to find the p-value? We say this is the test statistics. This is our p-value, right? For testing about beta 1. So this is about beta 0, this is about beta 1. All right, so that means our p-value is very, very small. The p-value is less than 0.0001. It is very small, less than 0.05. So what we need to do, we need to reject the null hypothesis, right? And so that we have enough evidence to support our alternative hypothesis, right? So what is our alternative hypothesis? The alternative hypothesis say the beta 1 not equals to 0. So what does beta 1 not equals to 0 mean? It means if beta 1 is not 0, that means our regression is meaningful, right? Also, it means there is strong or significant linear relationship between x and y, right? So here we can say we have enough evidence to support that the regression is meaningful. All right, So the last question, 95% confidence interval for the true slope beta 1. Now we need another confidence interval, but this confidence interval is not for the mean value of y or the prediction value of y. It is for the slope beta 1, right? So what is the formula of it? It is before that. It is, this is the example, this is the confidence interval for the true slope beta 1, right? So this is the formula of it, right? Okay, now let's come back and then just write down the formula b1 plus minus t star times the standard error of b1. All right, so just plug into the formula b1. What is the value of b1? We say from the output, this is the b1, right? Okay, so it just it is negative 0.1233. What's next? 3316. All right, plus minus the t star, since n not changed, still 95%, your t star is still 2.12, right? Times the standard error of b1. So what is standard error of b1? It's this, right? So which is 0.0125, 12514. Right, and then you just make the calculation. You should have the confidence interval from negative 0.1495 to negative 0.0965. All right, once you have the confidence interval, you need to interpret it, right? So how you can interpret this confidence interval for beta 1? We say when we make the confidence interval, we need to combine the interpretation of the confidence interval and beta 1 together, right? So we say we are 95% confident that, right, normally we say we are 95% confident that the true slope beta 1 will fall in this range, right? But it doesn't make sense, right? Because nobody will know what is beta 1 if it is not in this course, right? So we say we are 95% confident that we need to interpret what does this beta 1 mean, right? So we say it is when x increase by 1 unit, y will increase by this much, right? So we need to plug in the real meaning of x and y. So we say when the x is the mileage, right? So when the car has 1 more mile, the car's price. Now you need to be careful again. We do not interpret a negative confidence interval. So what if we have a negative confidence interval? What does that mean? It means when x increased by 1, y decreased by the other way, right? The positive value of it. So we say we are 95% confident that when the car has 1 more mile, the car's price will decrease by, now since we changed to positive, we need to change the order of it also, right? So it would be 0.0965 to 0.1495, which is by this dollar, right? Did we miss anything? We say on average. right? Because we are talking about the population parameter, we say on average. All right, so now we are done with the in-class practice. Hope you can understand all of these questions now, and just let me know if you have any further concerns or questions. And for the next two chapters, chapter 18 to 19, the multiple regression, you should have more questions than this chapter. You will have two in-class assignments. The first one, just to fill in the blanks. The second one, you will have more very similar questions in your exam, right? So it will be combined with the simple linear regression and the multiple regression, right? So be careful about the difference. All right, so that's all I want to talk about for now. If you have any questions, just let me know. All right.